Okay, so this is what your table looks like. For error, you can write undefined. It doesn't matter to me. And we'll talk more about what those errors mean tomorrow. But let's answer these questions today. So using the graph or the table, it doesn't matter. What is the x-intercept of this function? Good. So I'm going to go ahead and write it as an ordered pair. Now let's look at the factors and see if there's some kind of relationship between the factors and that -5. What do y'all think? Is there some kind of relationship? Yeah. So what we're going to do, and again, we'll talk more about this tomorrow. The factors they have in common today, we're going to put a box around them because they are special factors, but we're not necessarily going to use today. But if you take out the factor they had in common, whatever makes this one 0, that's going to be the x-intercept. So let's just jot that down. That is the 0 of the numerator that didn't match the denominator. And that's not a coincidence. That's going to happen every time. That factor is going to give you your x-intercept. All right, so what two x values is G not defined? Good. So let's look at the factors here. What do those zeros match up with? Denominator. Now, does that make sense that that would be undefined? I hope so. Because if either one of these were 0, your denominator would be 0. You can't divide by 0. So that's why the function is undefined there. So we're going to say these are the zeros of the denominator. I zoomed in too much. And in a second, we're going to talk more about the domain, but we're going to make a note that these are not in the domain because we cannot divide by 0. All right, so number 4, there's a good chance that you got close to the right answer but didn't get the right answer. And it's okay because I don't think you guys have ever looked at a graph that has a hole in it before. This graph has a hole at x equals 3, which means we can't include that in any of our intervals. So the function is greater than or equal to 0 in this little region right here. So it's where it's above the x-axis and it's until we get to that hole, and then on the other side of that hole. So we're going to describe those regions. And if you messed it up, it's okay. We're going to get it right. So that one that's all to the left of -5, that's going to be from -infinity to -5. Should we include -5 in our answer or not?
Yes.
We should. Good. So we'll do a bracket. All right, then we're going to do this U. And we're going to describe the other two sections. So what this graph is going to do, and you haven't learned it yet, it's okay, but it's going to get closer and closer and closer to where x is -1, but it's never going to get there because if it got there, it would be undefined. So we are not going to include -1 because it's not in our domain. And we're going to go and get as close to 3 as possible. So we're going to use 3, but not include it. And we're going to do another U, which stands for union or and. And then we're going to pick back up on the other side of 3. So we're not going to include it and then go to infinity. All right. So I think some of you got close to that. Did any of you actually get that? I think.
I've got a question.
Okay.
What does the bracket mean in front of the -5?
Okay, that's a good question. So the bracket means, for after the -5,
Yes,
it means you include it in the answer. So because it's equal to 0, it's included in the greater than or equal to 0. And then the other two numbers are not in the domain, so we cannot include them. All right, I'm going to give you two papers. So this second sheet is going to be like, we're going to keep adding to it like every day this whole week.
Let's get started next year.
All right, so let's go to the one that's got the big box at the top first. All right, so we're going to focus on the domain and the intercepts of rational functions today. But first, you need to know what a rational function is. So a rational function is of the form f of x equals, and then you have a fraction. So rational is just another word for fractional, basically. And then we're going to have n of x divided by d of x. Why do you think I chose to use n and d? Good. So anytime I'm talking about n, I'm talking about the numerator. D, I'm talking about the denominator. And then both of those, n and d, are polynomials. So that's why pretty much typically you do rational functions right after polynomial functions, because this is a polynomial divided by a polynomial. Okay, so the y-intercept is found the same way you always find the y-intercept, and that's by plugging 0 in for x, so by finding f of 0. And then a lot of the other characteristics of rational functions are found by factoring the numerator and the denominator. So factoring is an important algebra skill that you are definitely going to need to do everything we do this week. All right, so then all the zeros of the denominator must be restricted from the domain. So anything that's going to give you 0 in the denominator cannot be in the domain of the function. And then any zeros of the numerator that is, or I should say that are not in common with the denominator is an x-intercept. All right, now when we were figuring out with polynomial functions where they were greater than or equal to 0 or less than or equal to 0, I showed you how to do a sign chart, but most of you wanted to just do the little graph. Well, the graphs on rational are way more complicated, so we are going to do a sign chart for this type. And so we're going to create a sign chart using all zeros from the numerator and denominator to find when f of x is greater than or equal to 0 or f of x is less than or equal to 0. All right. So let's look at number 1. We're going to do all the things. Don't be surprised on the AP test if on the multiple choice they just ask you to do one thing. If they just ask you to give the x-intercept or just tell where the function is greater than or equal to 0. But we're going to go ahead and just practice all of them together. So the first thing we want to do is factor. All right, so the numerator is the difference of squares. And the denominator is just regular trinomial factoring. All right, now, even though we're not really using it today, if there are factors in common, I do want you to go ahead and just put a box around them. And we'll definitely talk a lot more about that tomorrow. Okay, so for the domain, what you're going to do is just look at the denominator, and anything that's going to make that either one of those 0 cannot be in the domain. So what can x not equal? -4 and 1. Good. All right, so I'm just going to write over to the side what we did there. You're just going to say x does not equal the zeros of the denominator. And then for the x-intercepts, we're going to look at the numerator and anything that we didn't box off that is in common with the denominator. So anything left over, whatever makes it 0, is going to be the x-intercept. So that's going to be 4, 0. And that was zeros of n of x that are not in common with d of x. And for the y-intercept, we want to put 0 in for x. We can put it into either form, either the factored form or the original. I think it's way easier to put it into the original because what you can do is anything that has a, whoops, let me try that again. Anything that has an x, you can just cover up. And then what does that leave you with? Yeah, -16 divided by -4, which is just 4. Yeah. All right, so I'm going to write f of 0 using unfactored form. But it will work in any form. It's just more difficult to do it in the other form. All right, and then D is definitely the most challenging part of today's lesson. So what we're going to do is go ahead and draw a number line. And we wrote it above, and it's also typed down here that we're going to use all the zeros from the numerator and the denominator. So that's going to be -4, 1, and 4. So we label those on the number line. And I should have put this second part in a different order. I didn't think about it till I started teaching it today. We're gonna talk about it in a different order. So if the 0 came out of the denominator, you're gonna need to use an open circle because the function cannot equal, or the x cannot equal that value because it's undefined. And then if it came out of the numerator, it's going to be closed. All right, so -4 was from the denominator, 1 was from the denominator, and 4 was from the numerator. And when we're talking about writing your answer in that interval notation, oh, it's not on here, sorry. Does the open circle translate to parentheses or brackets, do you think? Open circle is going to be parentheses. And closed is going to be brackets. All right, so what we're going to do is test a point in each region. And for this particular problem, are we going to want to get positives or negatives for our answer? Positives. So in this case, we're looking for positives. All right, is someone knocking? It looks like it's yours. All right, so the number on the left of 4 that I'm going to test is going to be -5. In between 4 and 1, I'm going to test 0. In between 1 and 4, I'm going to test 2. I'm going to go back and color code these. All right, and then on the other side of 4, I'm going to test 5. Now, have we already plugged in 0? Yeah, that was our y-intercept. So this one we already know the answer. When I plugged in 0, I got +4. So I already know that's a positive. So I'm not going to plug it in again. There's no reason to. All right, and then for all these other regions, because I had 4 factors, I'm going to go ahead and do 4 little sets of parentheses on a fraction. And I'm going to assume these questions will be on the non-calculator part, because if you had a calculator, you could just look at the graph and tell these answers really fast. So I'm just going to do it without a calculator, but it's not going to be difficult, because when you plug those numbers in, we're just going to get positive or negative. We're not going to care if it's -9 or whatever. We just need to know if it's positive or negative. So when I take -5, it's kind of small. When I take -5, and I plug it in to this factor, am I going to get a positive or a negative? Negative. So let's put a little negative symbol there. All right, I'm going to take -5 now, Torin. I'm going to plug it in for this. Am I going to get a positive or a negative? -5 minus 4, positive or negative?
What?
-5 minus 4, is that positive or negative?
Positive.
Nope. -5 minus 4 is like you owe $5, you borrow $4. So it's negative. It's okay. All right, then I'm going to take -5, and I've already done it, so I'm just going to do it again. -5 plus 4 is going to be a negative. And then -5 minus 1 is going to be a negative. So I have an even number of negatives. I'm multiplying and dividing. Is that going to give me a positive or a negative? Positive. So anytime you have if you're multiplying and dividing and you have an even number of negatives, it's a positive. All right, let's go back and do the same thing with 2. So we're going to take 2, and we're going to add 4 to it, and that's definitely a positive. When I take 2 and I subtract 4 from it, what are we going to get? Negative. And that's the same factor, so it's positive. And then when I subtract 1 from it, that's a positive. So is this going to be positive or negative? You have a question?
Yeah, where like x equals -5, x equals 0x, where do those come from?
Okay, so do you know where these came from, the dark blue ones?
Kind of.
Okay,
They came from up top. I don't even know that.
They came from whatever is going to make all of these 0. Okay, and then you have to test a point in each region. So the first region was to the left of -4, so I just chose a number in that region.
You just choose a number between them?
Yep. Okay, you guys plug in 5 and write if you would get positives or negatives for me, please. All right, so that one's all positive, so it's going to be a positive. All right, so because this is greater than or equal to 0 is what we're looking for. Anything that has positive is a solution region. So I'm just going to darken those solution regions. Now we cannot just cross over an open circle. If it's an open circle, it has to break right there. So we have 3 regions that we're going to describe for our solution. All right, so I'm just going to start at the left. The first one is from negative infinity to negative 4. And then because it's an open circle, we're going to do a parenthesis. And then negative 4 to 1. And again, open circle is parenthesis. And then your last region, we're going to do a bracket because we have the closed circle 4 to infinity with a parenthesis on the infinity. All right, so you guys look at that. Look at the brackets, parentheses, numbers, and see if there's something you're still not sure where it came from. Are y'all okay? Okay, we're going to do another one. It's just the same thing, same steps. All right, so when we're needing to find the domain and x-intercepts and where a function is positive or negative, we definitely need to factor it. All right, so I did take a step where, because this was multiplied by itself, I decided I would go ahead and write it as that squared. That's just going to save us some time as we go through this problem. Normally, I'll tell you, it doesn't matter to me how you write it, but in this case, it is going to save you time if you do write it that way. All right, so let's start with the domain. The domain, we're always looking in the denominator, and anything that's going to make that 0, we have to kick out. So what do we have to kick out of the domain? -2 and 2. So we're going to look at the factored version. Anything that would make either one of those factors 0, we kick out. All right, did we have any common factors in the numerator and denominator this time? No. So this one is going to have multiple x-intercepts, which is fine. You can have multiple x-intercepts. Do you have to have an x-intercept? You don't. So it's okay if your function doesn't have an x-intercept. This one has 2. So we look to see what's going to make this equal to 0. What do you think? 0. And then the other one is going to be -3. And then for the y-intercept, I would still go back to the original function. And anything that has an x, it becomes 0. So what does that leave you with on the numerator? Leaves you with 0. And so 0 divided by -4 is just going to be 0. It does make sense. So if 0, 0 is the x-intercept, it's also your y-intercept because it crosses both of them. So you can just automatically bring it down because there can only be one y-intercept. All right, here we go. Let's do our number line. All right, and then anything that makes that makes the numerator or denominator 0s, we have to include. Now on this one, we are gonna have to test a decimal value, but it's gonna be fine. It's not really gonna be any harder. You're gonna be able to do it. So we're gonna pick a number in each region. So this one in between -3 and 2, I'm gonna do -2.5. You could do -2.1, it doesn't matter. It just has to be in between those. All right, and then I'm gonna go ahead and set up all my parentheses. All right, looking at your factors, is there one factor that's always going to be positive? There is. Which one is it? It's always going to be positive no matter what you plug in. This one. Because whatever you put in for x and you square it, you're going to get a positive. So I'm just going to go through and I'm just going to make all of that second factor in the numerator positive. And we don't even need to test anything there because it's automatically going to be positive. All right, so I'm just going to go ahead and start plugging in these values. So when I put -4 in for x, it's just negative because it's -4. All right, and then -4 plus 2 is negative, and -4 minus 2 is also negative. All right, odd number of negatives is a negative. Now in this case, we want negatives. And then I'll put in -2. Oh, I forgot something. Sorry. Before we get going too far, let's decide if we have open or closed circles. What do you guys think about -3? Open or closed? Did it come from the closed? If it comes from the top, it's closed. If it comes from the bottom, it's open. All right. What about -2? Good. 0.
Close.
Good. 2. Nice. That's an important thing to not forget, even though I almost forgot it. Okay, let's go back and plug in -2. So when I put it in for just x, it's going to be a negative. -2 plus 2 is still negative, and -2 minus 2 is negative. So that's going to be a negative. Right. And then when I put in -1 for x, that's a negative. And if I put it in for this one, -1 plus 2, what do y'all think? Positive. What about -1 minus 2? Negative. Right. Even number of negatives is a positive. All right, you guys try to do the last 2 sections on your own. If you have a question, please let me know. Right, so again, we want negatives for our answer. This one is a little different because right here at -3, it's a solid circle. So we can just pass right over it. We don't have to break at solid circles. All right, and then the other section where the function is negative is between those two. All right, so you guys try to write the interval notation for that shaded region, please, if you haven't already. All right, what questions do you guys have? All right, it's gonna be a while before you can do this without just like really thinking about every step because this is the first time you're seeing it. Yes.
How did you get positive for the x equals 3 on the top left?
X equals 3 on the top left. Oh, okay. Are you talking about this one? Because you put 3 in for X, since 3 is positive. Yeah. What other questions do you guys have? Yes, ma'am. Okay, that's a good question. Okay, so are you okay on when you do open and closed circle? All right, once you get the graph, if it has an open circle, it's going to be parenthesis. Now, infinity always has parentheses. And when it has a closed circle, you're going to do brackets. And infinity is always parentheses. All right, what other questions? Okay, on that sheet that says continuing examples, we're only going to do A and B part. It's not going to take very long to do it, which is good because we don't have very much time. And what's going to take the longest is going to be the factoring parts. All right, so on the numerator, it's kind of challenging to factor because we want to get 2x squared, which some of you look like you're already done, which is good. But to get 2x squared, we are going to have to do 2x and x. And then we need to get 3, so it's going to be 3 and 1. So we have to decide like where we put the 3 and where we put the 1. So when you do all the multiplying, you'll end up with -1. Do you guys know where you put the 3? Do you put the 3 with the 2 or on the other one? Anybody? You put the 3 with the 2. And then it needs to be negative. So you get negative, just kidding. There you go. You get 2x minus 3x is -1x. Right, and then the denominator is easier because you just need to multiply to get 3 and add to get 4. That's obviously 3 and 4, and all the signs are the same. So what can x not equal? Very good. So anything that's going to make that denominator 0, x cannot equal. And then these are the same, so I'm going to box them up, and we'll do more with that tomorrow. Now, this x-intercept is actually more challenging than the ones we did in class. Is your x-intercept, looking at this factor, just going to be 3? No, because that is 6 minus 3. That's definitely not 0. What is it going to be? 3/2. Now, if you can't do that in your head, it's perfectly fine. You just take that and set it equal to 0 and solve for x. It's not hard to do in your head, though. So if there is a coefficient on that x, you still do the opposite and get 3, and you just divide by that coefficient. You probably remember that from Algebra 2. All right, now this wants us to graph it. So on the x-axis, we are going to put a point at 1.5 because that's what 3/2 is. All right, and then for your y-intercept, we're going to put 0 in. I'm just going to go ahead and use the original. So what do you get when you put 0 in? -1. And I will graph that. All right, one more. We can finish it real fast. Oh, it's fast. The denominator doesn't even factor on the back. Right, and then the numerator is just going to be x plus 4x minus 3. What can x not equal? 1. This one doesn't have any common factors, so both of those factors on the numerator are going to give us x-intercepts at -4 and at 3. So I'm going to go ahead and graph those. And then for the y-intercept, I'm going to put in 0, and that's going to give me 12, which I have to extend my y-axis just a little bit. All right, so I have a worksheet with 3 problems where you're doing all 4 things, not doing any of the graphing today with them. I highly recommend that you do them because you've never done this before. So if you don't practice it, you're going to be kind of lost. And all these things just build and build and build. So I don't want you to get lost in the first day. I just want you guys to know that tutoring starts this week, and I like to do it on Monday, Thursday, because Wednesdays get kind of busy for me. But this week it is going to have to be Monday, Wednesday, because I have a meeting on Thursday.
Here on my notes.